Hey everybody, Freddy here with another video. This is the continuation of the series of connecting an on-prem environment to an Azure environment using a site-to-site VPN with a central firewall and a hub and spoke configuration, as you see right now on your screen. We have already created the on-prem connection to the hub in a previous video. If you haven't watched that video, please do so. Now we're going to focus on the right side of this configuration, which is setting up the spokes and connecting that through the hub and sending all the traffic to the firewall. I hope you enjoyed this video. Please like this video and subscribe to the channel. Okay, so let's get started with this video. In the previous video, if you haven't watched that video, please do so. This is when we focus on the left-hand side of this diagram, when we connect the Sonic Wall firewall that is on-prem to Azure Virtual Gateway. In this video, we're going to continue with the design, but this time we're going to concentrate on setting this stuff up here, which includes setting up other VNETs like corporate VNet and spoke VNet, and there's a spoke 2 VNet, and we're going to do VNet peering between these two, the hub and the spoke on the two VNets, and we're going to route all the traffic through this firewall here, which is the 10.1.1.4. We're going to route all the traffic from corporate VNet through that firewall to the on-prem system, which is the Sonic Wall. We're also going to route all traffic from this VNet to the spoke VNet through the firewall. And the other one we're going to do from the spoke VNet, we're going to route all traffic going to the 172.1.7, which is the corp VNet. We're going to route that traffic through the firewall, but not the traffic going to the on-prem. So we're going to use what we call the user-defined routes to do that and to manage the routing. All right, so let's go ahead and get started. Let's set up the corp VNet. So we go back to our portal, virtual networks. So we only have our hub VNet, so we are going to go ahead and click on create. The next thing we're going to do is we are going to continue with our design, and we're going to create a VM, a virtual machine in this VNet here. So let's go into virtual machines, and let's go ahead and create a virtual machine. We're going to use the same resource group. We're going to call it corp VNet VM. Just keep things consistent. Central US, and no infrastructure redundancy required for this test. We're going to use that small VM. It's going to be in the corp VNet subnet, which is the 172.1.7.1.0, which is this design here. And we're not going to use a public IP address. And that's about it. We're going to leave all this as is, and no tags. Okay, the VM has been created. Now we can go to the resource just to make sure that everything is good. And what is the IP address? The private There is no public IP address. There's only a private IP address, which is 172.1.7. 17.1.4, which is the one that we have here in our design. Okay, so now we can test the connectivity. Let's go ahead and click on our terminal window here, and let's go ahead and look at our design. So right now I am, this computer it's on-prem, so this is 192.168.5. I don't know if it's 216, probably not, because I have DHCP, so it changes. So if I ping 10.1.1.4, I'm able to get to it. Ping 172.17.1.4. That one we're not able to ping yet. There are a couple things that we need to do before we can ping. We're going to set up the VPN peering, or the VNet peering between the two VNets. So let's go ahead and do that. Virtual networks, let's go to hub. On the hub, we're going to set up peering, click add. We're going to call it hub to corp VNet. We're going to allow traffic both ways, and we are going to set to use this virtual router gateway because everything is going to be routed through this hub. We're going to use this virtual network gateway or router server. On the remote, this is the remote connection here, we're going to call it corp VNet to hub. This one we're going to use the subscription, and virtual network is going to be the hub, the corp, because it's the one on the right hand side. So again, we're doing the peering from this one up to this one. So in this case, allow traffic from both sides. In this case, we're going to use the remote virtual network gateway or server because again, we are on the corp VNet. We're going to use the central as the router. Okay, so click add. This is validating, and let me see what is happening here. Okay, successfully created the peering. So there it is, it's updating. Now it shows connected. So now there's a connectivity, but we probably do not have traffic yet because the sonic wall does not know about that subnet. So we need to in order to make it work, we need to set up the sonic wall to point to that subnet. So let's go to the sonic wall. The first thing we need to do is we need to add an address object for the new subnet. I'm going to add an object. I'm going to call it Azure 172.170 network, and it's going to be in the VPN zone assignment, and the type is going to be network. The network's 172.170.0.0.0 255.255.0.0. Click add. So we have an address object. Now we need to set up the routing. So we go to routing, click add. The source is any. The destination is going to be the Azure 172.170 network that we just created. The gateway, we're not going to set the gateway. We're just going to set up the interface. The interface is the FMD to Azure tunnel interface. If you don't know where this one came from, please watch the video about connecting the sonic wall to Azure, and that will show you how we created that. So click, I'm going to put this in the background so you can see when it starts to work. As soon as I do the routing, click OK. And there you go. As soon as I set the routing, then I'm able to ping 172.1.7, which is this here. So what am I doing right now? I'm sending the traffic all the way from this system here across the VPN through this virtual gateway up the VNet peering up to the corp VNet here. all this traffic is just flowing through the VNet, is not flowing through the firewall yet. Okay, let's SSH into the firewall. Okay, so now we're on the firewall. At this point, we're connected. We're SSH'd into the 10.1.1.4. One of the things that I would like to do is I like to do a TCP dump host. And what we're doing is on the firewall itself, we're going to see what kind of traffic is flowing from the 172.17.1.4. Oh, excuse me. If you don't have TCP dump, you can add it on the firewall. I already have it. So at this point, I'm not sending anything. I'm not receiving anything from the firewall because the traffic is not flowing through this firewall. So that's the next step. What we're going to do is we're going to set the user-defined routes on this corp VNet so that all traffic flows through the firewall like this, going to the on-prem and also going to the 172.1.8, which is not set up yet in our portal. So let's go ahead and do that. So go to hub, go to the portal. Let's go ahead and go into the virtual networks. On the core VNet is where we need to set up the route. So let's go ahead and look for route tables. Let's go ahead and create a route table. We're going to put it in the same resource group. I'm going to use, just to keep it consistent, I'm going to use the same Central US, and I'm going to call it corp VNet user defined route. You can give it whatever name you want. Make sure that the propagate route says yes. Let's go ahead and do next. And create that. This creates an empty route table. And while that's created, let me go ahead and move this over to the side so we can see when the traffic starts to flow through the firewall. Okay, so this user-defined route is created. So now we're going to go into routes. So we click on excuse me, routes. Click on add. We're going to give it a name. Route firewall. So the destination is going to be an IP address. The destination was 192.168.5.0/24. Again, because that's the on-prem. So we're adding this route table to this VNet, and we're telling it what any traffic that is going to 192.168.5.0 is going to go through the firewall. So the next hop is going to be a virtual appliance and is 10.1.1.4. Okay, so click add. Just by adding this route, it's not going to change anything. Again, this is just a route table. It's not associated with any subnet. As you can see here, there's still nothing, no traffic flowing through the firewall yet. Until we assign it to a subnet. So we're going to associate it with the subnet. So click subnets, associate, corp VNet, and then the corp VNet subnet, which is this subnet here, and we're going to click OK. It takes about a minute or a little bit more than a minute for the traffic to start flowing, for the route tables to converge and update. And there you go. Now the traffic flowing from the on-prem is going through the firewall, and it says that it's failing. The reason it's failing is because we still need to do one more step. As you can see, the traffic is flowing, but it's not getting to the destination. The reason is because the firewall is not set to allow routing. So let's go ahead and set that up. Let me put this here. and let me move this down here. Okay, so what we're gonna do is we're gonna go to the VM itself. So go to the virtual machines. Let's go to the hub VM firewall. We're going to go to the network interface of this firewall. Click on networking, click on this network interface. And here under IP configuration, we're going to allow IP forwarding. This is very important. So we're going to enable this, allow IP forwarding so that this firewall can receive the traffic and forward it to the destination. Okay, so this IP forwarding has been enabled. However, we still see that the traffic is not being routed. So one of the things that we need to do is we need to enable IP forwarding on the server itself. So let's go ahead and SSH into the Linux box on the central hub. We can do a sudo sysctl -w, which means write net.ipv4.ip forward equals 1. So now what we're telling the system is go ahead and overwrite the 0 and put a 1 in there. So now it changes it to a 1, and as you can see, the routing starts taking place. Okay, so now that the traffic is flowing, one of the things that I want to point out is the effective routes. When you go to the subnets themselves, let me go ahead and look at the route table. When you look at this route table, I'm looking at the spoke UDR table, which is this one right here. I am on this UDR or user defined route. I only added one route. This route that I added, if you notice, is to on-prem 192.168.5.0. This specific route just tells this subnet where to send traffic that is going to this subnet, and we assign it to a subnet. But if you look at the effective routes of this route table, there's a lot more going on than the one that we did. The one that we did, some of them say none, so we don't have to worry about it. But if you notice on the bottom is the one that we set up, and it says that it's a user-defined route. So this is the one that we created, and it says that it's active, and it tells it to go to the virtual appliance. However, if you go up to the other ones here, we can see that there's other ones too, like active 172.1.8 is virtual network. The 10.1.00 is a Vnet peering. So if you notice here, there's one that was pointing to that, the one 92.168.5.24, but because we created one which is a user defined, this one overwrites this route entry here. So this what we see here is what is called the system routes. So this system routes do not go away when you set up a user-defined route table, or when you set up a route table, they don't go away. So they're still there, and this is why the traffic, if you don't specify anything in the route table, the traffic is going to flow through the regular method. So in this case, if I did not specify a rule for the 172.1.8, and here I showed that I would, but I didn't. So if I don't set up a specific route, then the traffic is going to flow through the normal routing that Azure has. And that pretty much concludes the test. We did not get to do this spoke VNet because it's pretty much the same process. If you do this peering, then you can add it to the on-prem and the traffic flows back and forth. And this is how you set up a user-defined route, and this is how you set up a hub and spoke design like this, and how you can shape the traffic. I hope this was beneficial to you, and I hope you learned something. That's it, my friends. Now the configuration is complete, all the traffic is flowing, and pretty much the configuration is completed at this point. Pretty painless, right? I hope you learned something. I hope this video was beneficial to you. Please like the video and subscribe to the channel for more videos like this. And also, please leave comments down below. Let me know how you did. If you try to set this up, let me know. Did you run into some problems? Did you run into some issues? I would love to hear from you. So please leave your comments in the comment section down below. And until next time, take care.